When the Canon game activity is created and its view is inflated, the Canon view object gets created and its constructor gets called, and it receives as arguments a context and also an attribute set, and the attribute set represents the various attributes that we specified in the layout file. Now, the first thing you do in this type of constructor for a custom view is call the superclasses constructor, and then you begin doing your custom initializations. We first grab a hold of the context, which is our activity, and we cast that to type activity and store it so that we can interact with the activity programmatically. Then we have a key thing that we do here at line 96. We use the inherited getHolder method from class surface view to add a callback for the surface holder dot callback listener, saying that this class is the one that implements the interface. And again, if you go back up here to the beginning of the class definition, you can see that we've implemented surface holder dot callback, and the surface holder dot callback interface has methods in it such as surface created, surface destroyed, and also one for when the surface's size changes as well, as you'll see in a few moments. So it's important that we register that listener so that we can deal with those various surface holder events, if you will. Next, we set up the lines that represent our blocker and our target as new line objects, and we also define the cannonball as a point object. And remember, when you're inside of Eclipse, you can hover over any variable to see what its declaration is. So in this case, cannonball is an instance of type point, as declared back up above in the instance variables. At line 104, we define a Boolean array called hit states, which has the same number of elements as there are target pieces, and we'll use the Booleans in this array to determine whether any given piece of the target has been hit yet. And at lines 107 through 116, we set up our sound pool and load up the sounds. Now, the sound pool has 3 arguments to its constructor here. The first one indicates how many sounds can be played in parallel. We'll only ever be playing one sound at a time, therefore we've used 1. The second argument is the stream that should be used to play the sounds. Now, if you look at the documentation, it says that for games you typically want to use the music stream, but there are actually 7 different sound streams that you can choose from, specified by constants in the Audio Manager class. Now, the last argument, according to the documentation, represents the sound quality, but the documentation says that this argument is not currently used and should simply be specified as 0, which is what we've done here. At line 110, we create a hash map of integers to integers, and we're going to use as the first integer the key in each hash map, one of the constants for the different sounds that we defined back up above before the constructor definition. And as the second integer, we're going to use what's returned by a call to soundpool.load, which gives you back an ID number that represents that sound so that you can access it and use it in your app. So soundpool.load takes 3 arguments as well. The first is the context from which we're going to obtain the resources, and that's our activity, and this is going to give us access to various resources in the resources folder, in our case the raw resources for the 3 sounds. You have to give it the resource ID for the file that you want to load. So for example, r.raw.target_hit represents the target_hit.wave file in the raw folder. And by the way, notice again that when you use these resource IDs, the file name extension is not part of the ID, which means you can't have multiple sounds in different formats that have the same name. So you couldn't have target_hit.wave and target_hit.mp3, for example. That would not work. Now, the last argument in here, according to the documentation, is not currently used and should simply be specified as 1. So we did that here for each of the 3 calls to soundpool.load. So again, we're building up our map of IDs that represent the target sound, the canon sound, and the blocker sound, and then separately the ID numbers for those actual sound files that are returned by the 3 calls to soundpool.load here. And then finally, the last part of the constructor sets up all the new paint objects that will be used for various aspects of our drawing on the screen. And this just creates the paint objects. As you will see, we will configure various aspects of the different paint objects in other methods.